Here we have a table. There's a lot of tables that we use in everyday circumstances, particularly in computers, things like databases. This table happens to be about the solar system, but what I want to talk about is not specifically about the solar system, but I want to talk about an instance where algebra arises in the study of tables like this. In fact, there's a lot of mathematics associated with databases. This is just one particular application, and it's a good example of algebra coming into play. So this table, we can see we have the planets and a couple of planet-like objects down the bottom. Pluto, poor old Pluto, recently demoted to a Plutoid status, and a few properties. We have size, small, medium or large, distance from sun, near and far, moon, yes or no. Yes, these actually do have moons. So, this is some of the information that we may have wanted to list regarding these planets. You might have wanted some extra columns here. That's fine, you can do that for homework. But I've chosen this table. Now, there's a lot of information on this table, and it's questionable as to whether it's the best way to present it. Certainly we can find very easily whether or not Uranus has size medium or Pluto is small. We can see that kind of information. So over here, we have a totally different way of representing the same information. All of the information of the table is on here, but now instead of looking for crosses, we now look up and down the picture. For example, if we want to see which planets had moons, so we go to moon yes, so here's the property that's in blue, and we look at all of the planets that are underneath it. So you can see Earth, Mars, Pluto, Eris, Jupiter and Saturn. I know these aren't strictly speaking planets, they're Plutoids. But this information is actually a much more pictorial way of presenting the table, and it gives us a lot of interesting information that's not easily gleaned from the table way of presenting. For example, you can see that the planets have been grouped in pairs here. That's not obvious at all from the table. And what does it really mean? Well, it says that as far as the properties are concerned, the properties we put along the top of the table, they were unable to distinguish between, say, Jupiter and Saturn. So as far as the properties we were interested in, these are indistinguishable. And the same is true for Pluto and Eris, Earth and Mars and Mercury and Venus. And this is actually an interesting example here. For example, these are classified as Plutoids and not planets. And you can see that the fact that they've already been isolated like that tells us that amongst the information we have, or the properties we're interested in, we already have enough to actually distinguish them. In other words, Pluto and Eris were already distinguished by being small, having a moon and being far. And in fact, we can also see that they're a unique pair that are far from the sun and it's small. We don't actually need the moon information to tell us that. We can also see that we can't get away just with the size being small and having moons because, for example, there is more than just Pluto and Eris underneath those two properties. Earth and Mars also have those properties. So this is a much more pictorial way of presenting the same information. Now there is a complicated algebraic process that underlies the production of this table and the way that information is contained. It's called lattice theory, and it's not the algebra of numbers like you see at high school. It's really an algebra of ordered pictures like this. So a very different instance of algebra. Unfortunately, it's a little bit technical to explain how to produce the picture, but the picture itself is easy to read.